Presentation following up on yesterday's lecture. If you do assume that there is a point at infinity and you call it a point, that is called projective geometry. It's still linear, very useful, even as complex numbers are useful, but is there actually a point at infinity? Obviously not. We inducted sphericity. I just showed you that the universe, our universal blackboard, this is for geometry, this is in the head. It has no straight lines, although they are in the background. We have spherical space to begin with, but what the Greeks taught us is to not begin with reality. Instead, you begin with a derivative reality. The derivative geometry is linear geometry. That's all science has ever used, is linear geometry. In the 20th century, actually a little before, we discovered that nothing is linear except by derivation. And that's why we use the calculus. The calculus is the tool, the only tool. It took a hell of a long time to develop calculus. From the time of Archimedes and before, everyone has used calculus. The Greeks used calculus. Everybody back to the misty beginnings of time, which is not in the jungles of Africa. Natural selection is a racist theory. Nobody knows where humans came from, and that's where science stands. And if you say you know where humans came from, it's because you were probably abducted by aliens. Because only they would know. Humans cannot know where they came from. We don't know where we came from. What we do know is that we did not come from the ecology. And it doesn't make any difference what these stuffed shirts say. So going back to the misty beginnings of humanity, calculus was right there at the start. The Greeks or whoever came before, the Babylonians and Egyptians and Indian and Chinese people and everyone else on Earth, back to about 6,000 to 10,000 years ago, where the story just, you can't figure out where anything came from. They were using calculus. Rudimentary by the method of exhaustion. This is a very well-named method, by the way. It will exhaust you to death. By the time of Newton and Leibniz, we had developed a methodical calculus of two forms, so that only one form of calculus will be considered correct. That's impossible. And so the relationship of reality to linear algebra is that of involution. When we use our number system, 1, 2, 3, 4, with all the numbers in between, which is infinitely densely packed. That's what John Horton Conway proved. Finally getting a definition of linear infinity. It's an infinity of infinities. That defines the line. In other words, it's fractalized. It cannot be computed. What's it? The circle. The circle, with respect to linear space, has a value of tau, 6.28 ... It's not a real number. Forget about the real numbers. That's a misnamed number system. Nobody has real numbers except I do. I have the real numbers. They are the ones that the Greeks used. The Pythagorean theorem is not based on linear numbers. It's based on square numbers. You do get that irrational number on the diagonal, except for the so-called Pythagorean triples. And you know the simplest one, and you may know more than one, but 3, 4, 5 is a Pythagorean triple. That might give you a clue. Your philosophical part of your mind may grind on that, and you may be shaking your head at the linear algebra physicists now. You're using irrational numbers? Dedekind's cut. We use Cantor's insane asylum method. We use calculus. That's the involute solution from the point of view of having begun at linear space on Earth to machine the numbers down to precision. That's what the calculus does. And to do that, there's always a little remainder called delta that you throw out. You can't throw out anything in the universe. You can't drag to the universal trash can and get rid of it. What the physicists say is that would be a black hole. There's your circular file. Just drop it into a black hole. That's hotly debated. What happens to the information when it's dropped into the trash can of the universe? That's not a trash can, dear. We're getting there. We began with linear geometry. It's now the year 2023. We're halfway through. We're at the end of July. What have we learned? Well, I think you know. Paradox, 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 paradox. But you have to start with what you have. That shows up in the Big Bang. That shows up in the supermassive black hole geometry. They're using linear geometry to compute real space. You cannot do it. Nobody has ever done it. But you can pretend with calculus. So calculus, you're going to need to know what that actually is. Here's the way out. You go back, not to square one, you go back to sphere one. The original sphere that's embedded in our minds. It's unbounded spherical space. Now, unbounded is the paradox. That is what we need to solve right now. It's the first question presented to a child who's looking up at the night sky. The first question from the heavenly court to the child is about infinity. And 2,500 years of linear algebra has made zero progress on infinity. Nobody knows what it is to this day. We have a bag full of numbers. We face tau. We face pi. We face the irrationality that exists from the start, ab ovo. That the relationship between the circle and the straight line through it is that the straight line is less. The diameter of a circle cannot describe the circle. The radius of the circle, which is half the diameter, cannot explain numerically the circle. Why not? Don't we have calculus? It throws out the remainder, the delta. Linear numbers are embedded in spherical space. The way we have correlated spherical space with its number system with our linear number system is on the irrationality of tau. Yet, it will in a moment. What's at the center? As I said, it's an imaginary center. Because it could be anywhere, so you're axiomatizing the system. It does have a center. Because it has an edge. We're going to use that fact to create the Bootstrap theorem. It begins axiomatically with the most insane thing you'll ever hear in your life, and after it clicks, you're going to realize it's true. We now have two numbers because we say we do. We have a number at the center of the universe and a number at the edge, and that's all we have. We have a number at the center of the system. This is called a space. It's a geometric space that we're creating in our mind to try to match it to reality. This is the correct way to begin, obviously. Total match on physics. The line, no. The sphere, yes. And here's why. We have two numbers and only two numbers. We're now going to use a principle that we learned from linear geometry to reapply mathematics to get the true basis of geometry, not from lines, but from the other line, the one that curves. I showed to you yesterday that the straight line is exactly the average of two circles. That if you have a circle and you bend it until it snaps straight, if you go another infinitesimal beyond that, it snaps into another circle. So the straight line is exactly between two circles, correct? But if you don't have the line, all you have is one circle. That's actually quite profound, but we don't want to go down the metaphysical trail yet. We want to get through this so we have the Bootstrap theorem for the number system of spherical space. And now comes the magic step. Get ready. We're going to assign two numbers. To the center is one number. And it's a two-component number. We're saying so. This is the axiomatic step of Euclid. Okay? So, we have a number for the center that's a two-component number. We have a number for the edge, and that also is a two-component number. And now we learn something from linear algebra. The center of the linear algebra system is 0, correct? That, according to my theory, which we're about to justify, that is an imaginary number in real space. There is no actual 0 in spherical space. Instead, at the center of the system is the number we just made. It's 1. We're using 1 instead of 0. Only it's in a two-component system. So you're going to need two numbers. We also have a number at the edge. And that's going to be something over 1. The one at the center is the same thing under 1. Those two numbers multiply to 1. And that's the multiplicative identity. Scratch that from your mind and put in the right term. I'm going to teach you the right way to conceptualize that. It's the proportional identity. 1 is the proportional identity. It's not multiplicative and it's not divisional. It's both. Because 1 does not affect the multiplicative divisional system. And multiplication and division taken together has a name, proportionality. And here's how you're going to know that that's true. By beginning the integral number system. And here's how it begins. It's centered on 1 instead of 0. So at the center of the system is 1. We're saying so, and now we're going to prove it. That the center of real space, physical space, is not linear 0. We're saying so. We're saying that it's 1, the multiplicative identity. I'll continue to call it that, but you should think of it immediately in your mind. It's the proportional identity. So here's the secret that unlocks the universe. Infinity. We're going to say that it is a number, and then we're going to prove that it's an imaginary number that replaces 0 and infinity. The two thorns in the side of physics are 0 and infinity. They have never been defined correctly. We're going to do so now. The actual number at the center is proportional to the number at the edge. And here's how we know that. Multiply them together. The inner number is 1 over infinity. The number at the edge is infinity over 1. 1 over infinity times infinity over 1 equals 1. We're going to say that that's the sphere, and that the sphere has a value of 1. If we can prove this, I think you see the implication. We lose all the problems that we've ever had in mathematics if we can make this work, because it's going to turn out to be rational. Watch. 1 over infinity is a rational imaginary number. We're going to say so because we haven't defined infinity yet. We're going to define infinity now. It's imaginary. And that's going to end up being the only imaginary number. The only imaginary number in the system is infinity. And now comes the magic. You make the center inversely proportional to the edge. We just did. So now the number at the edge is the reciprocal of the center. The center is the reciprocal of the edge. That will define them both as 1, because they multiply to 1. That is the Bootstrap theorem, part 1. Now we need to rationalize infinity so we can use it. This will be the solution of every paradox that exists in mathematics and physics, is the rationalization of infinity. This will solve the ancient paradox, including Olber's paradox, and the very paradox itself of the end or beginning of the universe, either in space or in time. We're getting to time, but right now we're just dealing with space. We want to know how to conceptualize space, but we have to have numbers. And they have to be rational, computable numbers. So far, we have an imaginary number at the edge, infinity over 1, that only exists because of another number. The number at the center is an imaginary number that is reciprocal to the imaginary number at the edge. And when we multiply them together, we solve Kurt-Gödel's incompleteness dilemma. Because, for the very simple and obvious reason that we just created a space called spherical space. We're saying so. We haven't proved it yet, but we're going to prove it now. That is the Bootstrap theorem. We now have a space that's bounded. It's no longer unbounded. We have a number for the bound. But in order for it to exist as a number that we can just say exists, it has to have a reciprocal number, and that is the arithmetic beginning of the system. It's not based on add. Add only exists on the line because it has a 0 center, but the circle and ultimately the sphere has a non-linear center, and therefore it is not 1. It can't be 1. I'm sorry, it's not 0. It can't be 0 because that's already taken by add. That is the additive identity number. And that's why we can get linear separation that works so well. You just take 1, you have your index, and then just keep doing it. Click, click, click. And you get a dual infinite series of positive and negative numbers that terminate at infinity. That does not work. That leads to madness and fractalization. But in the 2,500 years we've been using these absurd derivative numbers, we've learned how to compute them. And that is what got us technology. So it has the stamp of approval of the creator. We were blueprinted to begin with linear numbers. Now, we need to use them correctly for the first time. This is how to do it. The two-component number that we put at the edge has one rational number in it, 1. It's infinity over 1. So one of the two component numbers is rational. The other one is imaginary. Now we multiply them together. What happens to infinity? It cancels. And what you're left with is 1. That is not a 0, children. And that has a shape. It's a sphere. And that is the center of the universe. Now, the universe, as we've discovered from physics, has no clear center, or if it has a center at all, it's distributed among the protons, basically. And everywhere there's a proton, there's a center. The electrons prove that. There's a center there, all right. They go right around it in a sphere. So those protons constitute the center of the universe. And that's called gravity. The contraspin force that has to compensate for gravity, according to Newton's principle of reciprocity, you're going to have an equal and opposite reaction to the centripetal force of gravity. That is the rotational component of 4D space, which is no longer D. Because D is linear dimensionality, that's why you have the Einstein field equation. The linear solution is insane, and Albert Einstein proved that. Albert Einstein proved that our linear number system is insane. It does not work. And so we have a definition of gravity that's psychotic. What is the contraforce that balances the pulling in of all space, which ultimately ends up in linear geometry with the black hole inversion of space and time? Now you know why that sounds insane. It is insane. There's no 0 at the center of the supermassive black hole, and there's no 0 at the beginning of the universe because there is no 0 in physical space. What is there instead? You learn that from the difference between 0 and 1. 0 is the center of linear space, but 1 is the center of spherical space. And the Bootstrap theorem will now demonstrate that to you beyond any shadow of a doubt. Pay attention. We have two numbers, the center number and the edge number. You multiply them together, they cancel. The infinities. What are you left with? You're left with 1. It's got to be between the center and the edge. Doesn't it? Yes. So what is it? It's the equidistance between the center and the edge. That is a number. It's the number 1. So that is the value of the sphere. And that solves for tau, and that solves for pi. We don't have irrationality anymore. Yes, we do. Because you can't get rid of the irrational relationship. The relationship between 1, which is the radius of the unit circle, or sphere, is 1. It's linear. It's a straight line segment, so it's 1. That's how we make the unit circle or sphere. So what's the value of the surface? 6.28 for the circle, and double that for the sphere. Very interesting relationship between the circle and the sphere, which you cannot see using linear algebra. You can only see it using real numbers. These are the real numbers, the proportional numbers, the reciprocal numbers that form a two-component number system that always multiplies to 1. We just did it with the two bounding numbers of spherical space. When you multiply them together to get 1, you get the sphere. So the two-component number, 1 over infinity times infinity over 1, equals the sphere, having the value of 1 over 1. What does that do to infinity? It does exactly what we said it would do. It becomes imaginary. And that's the solution to the edge of the universe. There is an edge to the universe to the proportion that there is a center. And we know that there are both. We have somewhat roundaboutly discovered the edge. It produced the Big Bang Theory, so of course it's a linear psychotic solution. And we found the center. It's called the quark. And nobody knows what that is. They can't isolate it at CERN or in any of the cyclotrons. So we know that there is a center, but we can't reach it. We know that there's an edge, but we can't reach it. But we do know two things now that we did not know before. There is an edge, and there is a center. And that's where our understanding ends. Well, not anymore. You put them together. You multiply them together. You don't add them. You multiply them. That's called multiplicative space. And that's spherical space. But it's not multiplicative. That's not saying enough. It is. But it's also divisional space. Well, you certainly wouldn't want a zero in there since the universe has told us, and you can check this in the IEEE, is if you divide by zero, your CPU halts. That means your brain just shut off and now you're inert. So you can't divide by zero. Well, you don't have to. There is no zero in spherical space. What is there instead? There's one. Now we're going to show you what that means geometrically. When you have the center and the edge, and you assign two reciprocal numbers to them, one of the components being 1, which is unity, universe is unity. It is one thing, that's where we get the word universe, it's a 1. Where is it? How do we conceptualize this 1? Is it the distance from 0 to 1? No! That's linear derivative space, using a center point of 0. That is a derivative number system that we've been using for over 2,000 years, without even having defined it until the 20th century. But we used it, and we used it well with calculus. That gave us jets, electricity, and electronics. We get everything that way on Earth. But for real space, the real universe that a child sees looking up, that's not linear. And so you need another beginning. When you do this, what we just did, multiply the two infinities together, it cancels the infinities, and now you have bounded space. Bounded spherical space. There is a limit to spherical numbers. Max Planck proved that. And so we now turn to the most important discovery ever made in physics by Max Planck. And Albert Einstein came along later and used Minkowski's ideas to prove that Max Planck was right. That's where we got the Einstein field equation and the Dirac solution for wave space. Both of them come from an involute interpretation of infinity, where it's linearized. That cannot work. You're going to go crazy. And they have gone crazy. But if you begin logically and rationally, using what the universe taught us about linear numbers, you can now use linear numbers to compose the correct number system in proportional space. And what we just did is created a sphere. The center is inside the sphere, and that's imaginary. Outside the circle is space that goes to the edge. So now we have two spaces. The inside of the sphere and the outside of the sphere. Now we need the numbers to fill space. That's what we did with 3D. We took one line, made an orthogonal line, and if you do it a third time, you get cubic space. That's what science is built on, cubic space. Obviously, that's insane. Technically, it's irrational. That's why you have calculus, etc., etc. It's because nobody has solved for tau, nobody's solved for infinity, Nobody's been able to compute reality. All we can do is draw lines and then use calculus. That does not work in reality. You can force it to work on Earth to build things by turning irrational numbers into precision numbers. You can't do that in the universe. There's no trash can. There's nowhere to throw delta. You can't throw out anything. And so your number system is going to have to reflect the rationality of the universe as it exists. But we have to have the linear numbers. So where are they in the new number system? They're in the denominator and the numerator. Denominator is the one on the bottom, and the numerator is the one on the top. Restrict the range to whole numbers. The only exception is 1 over infinity times infinity over 1, creating the only imaginary number in the system. It's split. There's an imaginary number at the center replacing 0. And there's an imaginary number at the edge replacing infinity. And from that, you get bounded, rational, spherical space. Only whole numbers. Only natural numbers, beginning at 1. There's nothing less than 1 in the universe. Max Planck proved that. How did he do so? Let's review quickly what Max Planck discovered. He made 2 incredible discoveries in 2 of the most deceptively simple equations ever formulated in the mind of man. I'm going to teach you what the 2 equations mean. The first one is frequency times wavelength equals what? Do you know? F times nu. F and then a V. It's not really a V. It's the Greek letter nu. That's frequency times wavelength. You know what the smallest frequency is? It's 2, which means that the smallest, or you could say largest wavelength, is 1/2. When you multiply them together, what do you get? You get 1. Frequency times wavelength equals 1. What's the simplest number in that system? It's 2 times 1/2. And it is a 2. And there's no number smaller than 2. You may object, you say 1/2 is smaller than 2. No, it's not. It's equidistant from 1. I showed that to you, and let's look at that again real quickly. I'm going to load something here so you'll be able to see this. Pardon me, I need to get to the right screen again. I'm still fumbling around with this stuff. So I'm going to load a file from my online. I hope you can see this. I hope you're seeing that. Oh, yes, you are. Good. Well, it's not perfectly centered, so you're not going to see everything. I'm clicking on one of these to load it. And I don't want to save what's already there. Probably should have, but okay. Now let me make sure you can see that. OP is the outside number. IP is the inside number. This is the circle. I'm highlighting it, I think. I need to get the right screen. There's the circle. There is IP. And there is OP. This is 1/2. This is 2. This circle is 1. 1/2 times 2 is 1. When you move OP towards infinity, IP goes to the other infinity. The center is 1 over infinity. This number is less than infinity, but greater than 1. This number, IP, is less than 1, but greater than reciprocal infinity. You cannot reach this number. It's imaginary. And the one towards which OP is going is also imaginary. There's a reflection. If you take IP all the way to the center, the entire system disappears. If you continue, it reformulates on the other side. And then it locks at -1, locks at 0, and locks at positive 1. Therefore, this, with IP at 1/2, that's the wavelength. OP is the frequency. And this number 2/1, the frequency, together with the wavelength 1/2, multiply to the radius squared. That's called inversive geometry. You'll notice that when it's 1/2 times 2, it multiplies to 1, which is the circle, but the circle has been divided. And this arc, right here I'm highlighting the arc, and this sector cut by the arc is 60 degrees. That's a magic number on the circle. That's the circle divided into 6 parts. That's a harmonic number. These two numbers, IP and OP, are called harmonic points. They're also called reciprocal points. They always multiply to 1. These two numbers multiply to 1 no matter where they're moved. This is 3 times 1/3. This is 2 times 1/2. Every one of these two number pairs multiplies to 1. And now for Max Planck's second discovery. He discovered that number system. The wavelength frequency relationship is a circular function. And the two numbers describing it are reciprocal numbers with nothing but whole number components. 1/2, 1/3, 3/1, 2/1, whole numbers, rational numbers to compute spherical space with a 2-component number system. Now, what did Max Planck add to that changed everything? Look at the number 2/1 again. Just 2 and then a little line and a 1 underneath. Is that the number 2? In this case it is. What about 3/1? Let's move OP to 3. What's the number for IP now? Well, we can look at it. It's over here. Here it is. I'll click on it on the far left at the top. There is IP. What's its value? Well, it's not 1/3. It's 0.333 lazy 83. So that's not a linear number. So 1/3 is not a linear number, but it is a rational number. Starting to understand now? 2-component numbers are real numbers. They're the only real numbers in real space. No more division by 0. No more use of negative numbers. No more repeating decimals. Nothing but purely rational numbers that the Greeks themselves used exclusively are rational numbers. The secret is they must be kept in proportion. 1/2 cannot be linearized. You can linearize that at 0.5. Look again. So that seems to deny what I said. No, Sam, you're wrong. Because 1/2 is a linear number. Yes, it is. And now move OP to 3. Is 1/3 a linear number? No. So I'm right. And that's the proof of the superiority of this number system. Now, what can we do with it? Do what Max Planck did. Multiply them together. And what do you get? You get 1. 2/1 times 1/2 is 1. That's not what Max Planck said. He has another equation. The frequency times wavelength equals light speed. F times nu is c. F times nu is c. What does that mean? Now comes the interesting part. So see how far we've gotten here. Let's make sure we know where we're at. We've rationalized infinity. It's now the bounding number of space. And you can't reach infinity to the same proportion. You can't reach the center. You can't reach the edge because you can't reach the center. And you can't reach the center because you can't reach the edge. Because they're both imaginary. We said so. And that's consistent. And that gets rid of the imaginary numbers. And so you can forget all about complex numbers. We just solved for all the complex number system. It's still useful as a tool. Complex numbers are an extraordinarily good tool for analysis, linear analysis. We're not in linear space anymore. We don't need it. We integrated it. The complex numbers are now integrated into our system. We have the spherical function itself. This is what the Greeks were seeking. This is the rationalization of real space. And now physics can recommence. And here's what we need. The bounding imaginaries, we got those. The center and the edge are reciprocal imaginary space. The center of the circle is imaginary. In other words, there's no interior. And that number that I showed you going in, let's look at it again. This number. As soon as I switch screens again. This number IP that I'm moving inside the circle, it's going kind of in, and as it gets closer to the center, the rest goes to infinity. But as long as it's not at the center, it's real. These are the real numbers. If it gets to 1, it looks like everything disappears. But what's that? What is this point on the circle? It's a circular number. And so when you see this number going in, that's the wrong direction. Albert Einstein proved that. This number IP is not the number you want. You can use it. It's linearly real, but that's the problem. The inside of this circle does not actually exist. The outside does, it's space, but the inside is not space. It's imaginary space, and therefore it's representing something else. And that you see on the arc. Below IP, see the arc getting smaller? That's what IP is. It's the index on the circle. On the circle. On it. Not in it. So what you're seeing here is somewhat misleading. OP is real, except it's actually... This OP represents a ring. It represents a circle. But it's only one part of the circle. That describes the flight of the photon in free space. As the circle goes out, OP is going out, that's actually a circle. But what's IP? It's on the circle. It's perpendicular. So as OP moves, this point A moves. And so the real relationship is between A, which is a proportional number, as we'll show, and OP is its reciprocal. So this is circular or spherical space going out, and it's circular periodicity on the circle. And that's a different data type. And that's why nobody ever saw this. This number A represents angular momentum. This number represents space. But this number on the circle is time. And that is a different data type. It's not linear in any way. And if you are smart enough and clever enough, you'll realize that this point OP that I'm dragging out here, that is not linear either. This is a spheric component number. And this IP is a spheric component number. But OP does not represent this line, except you can use it in linear algebra as such. It works in linear algebra as well. But in spherical space, it works as well. but with two different data types. OP is space, but IP is time. And it's not inside the circle. It's on the circle. You can see A moving. It's changing the periodicity of motion. Angular momentum is motion. That is energy. Motion, energy, and time are not spatial concepts. They are not spatial. Time is not spatial. Motion is not spatial. And energy is not spatial. It's temporal. And it's measured in a term used by Roger Josip Bošković for his force curve balance of spherical space. The solution to the quantum paradox was discovered 250 years ago. That will be in the next lecture. That's an hour and 15 minutes. I've worn myself out again. I hope you pity me. I am the happiest man in the world. Don't you worry about me or my sickness or whatever it is. So now we have spheric space with bounding imaginaries, a totally rationalization of infinity. It's gone. It's now the bounding of the space, which is what infinity always had been. And now we know how to use it. It's imaginary. As we knew, but could not figure out how to rationalize it. Now we've rationalized it. So now we need the metric of the space. That will have to be in the next lecture. The metric is all important. Without getting the metric, all of our work is basically in vain. Not completely in vain, because the static geometry of spherical space, just space without time, just space, solves all the paradoxes in quantum mechanics, and solves Olber's paradox and the paradox of physical infinity. We now know the shape and constitution of the universe, but with one tremendous drawback: we have no energy-force balance. That is the metric. It's called space-time. Space-time is a two-component number. Max Planck proved that. But you know enough now. You can run with this. If you're clever, you've got it all. But here's a secret I'm going to leave you with just to think about: orthogonality. Einstein proved that space is orthogonal with time. I just showed you that he's right. And there's going to be an explosion because we have all the derivative solutions. The first thing you have to know is that time is not space. Remember I said that the straight line is not the circle, but then I showed you it is if you turn it. Time and space are inseparable. But what's the relation? They're orthogonal. In spherical space, Roger Josip Bošković got the algebraic curve of the quantum. He penetrated Max Planck's quantum to give us the inside of irrational space. The quantum itself has a structure that only Roger Josip Bošković figured out, and his work was forgotten until very recently. We're going to cover that in the next lecture. Thank you for tuning in. This is where it begins, and this is where it'll end. You have to understand what you're looking at right here. First, as a child. Unless you become as a little child, you will never enter the kingdom of heaven, and these physicists can't get in. They're trying to break down the door with linear logic. You're going to have to evolve. So I'm not only the new Euclid, I'm the new Darwin. And if you don't like that, good, because I don't either. You're going to be the new Darwin, and you are going to be the new Euclid. I won't be here. So, stay tuned to Anna Galactic for more secrets of the universe. I hope I didn't wear you out or overwhelm you. I just gave you the key to the universe. We'll be back with more. There's an infinite amount more, but now you know it's not infinite. The universe is finite. It's finite and it's a closed rational system that can be understood. Despite what these monsters are asserting about the universe, they don't know from cum sick'em. You're gonna have to listen to me now. But it won't be me. It's going to be you that corrects these bastards. So if you have a vendetta of any kind against these calculus freaks, you can get them now. But I hope you're more mature than that. I may not be, okay? I'm ready to depart this world. I have a vendetta. I've learned I'm never going to shake this vendetta. But there's something much more important than any man's vendetta. Is to get the children the truth! When they look at the sky, they want to know! Well, I do. I hope you do to a slightly better degree. In the next lecture, we'll be covering light speed and what it actually is. Light speed, so that you understand light propagation. The only way that we know about heaven besides gravity. And I'm going to discuss with you the true meaning of gravity, which has to do with Rudyard Joseph Boshkovich's force curve for universal space, which describes gravity, gets rid of the supermassive black hole mathematics, which are insane, solves everything about the Big Bang, which is gone. There is no Big Bang. And there is no such thing as a supermassive black hole, the way these artists' renderings draw it. And we're going to cover the quasar and the birth of galaxies, which I know from beginning to recycling. How the entire universe works. You may think that's pompous, pretentious, and precocious. Don't forget, I'm on my last breath. And this will be the last thing I ever say before I drop dead. And if you don't like it, I think you know where you can go. To the universities and learn calculus. And good riddance, you'll never make it. You'll make it if you listen to me. We'll be back. Keep looking up. Keep looking at this, okay? And the interacting galaxies. Take a look! Look! You want to see reality? You're going to have to look. If you're blind, you can see this better than a person with vision. I swear to God on that. We'll be back.